Okay, starter one, we have 12 plus 5 root x to the power 5 over 6x squared. So split it up, 12 over 6x squared plus 5x. Well, that's the power 5 over 2. Remember, flower power, 6x squared. 12 divided by 6 gives me 2. X to the power minus 2. And 5 over 6 doesn't give me a nice number. Take with powers. So 5 over 2 take with 2 just leaves me with a half. Okay, second one. We have y equals e to the 2x sine 3x. We want to find the exact gradient in terms of e and pi, so that's what exact means, of the curve when x equals 2 pi. So gradient means we differentiate. So I need a u and a v because it's a product. e2x sine 3x, differentiate them both. So 2e2x and 3 cos 3x. Remember, sine differentiates to cos. And then the rule is uv dash plus vu dash. So this times this gives me 3e 2x cos 3x plus 2e 2x sine 3x. Sub in the value of x, x is 2 pi, so I get 3e 4 pi cos 6 pi plus 2e 4 pi sine 6 pi. Now at this point, you could use your calculator to work out what sine 6 pi is and cos 6 pi is, or you might be able to spot them yourself. Sine 6 pi is just 0, and cos 6 pi is 1. So 2e 4 pi times 0 disappears, and 3e 4 pi times 1 is just 3e 4 pi. So that's my gradient, dy by dx. 3e 4 pi. Look, I didn't use a calculator, and if I did use a calculator, the only bit I would type in were these bits here. If I type in the e, my calculator doesn't give me e's as answers. It doesn't do exact answers with e's or ln's. So don't type it on your calculator. If you get a decimal, I want to be upset. Next one, solve modulus 5x minus 1 equals 3x plus 2. Well, the first thing to do is draw a sketch. So calculator ready, see if you can remember how to do the sketch. So options, numeric, absolute, 5x minus 1 and 3x plus 2. So if I zoom out, I'll just go up just to see, yeah, so they intersect twice, look. So I've got something that looks like that, and something that looks like that. So this one here is the positive branch. So I'm going to do 5x minus 1 equals 3x plus 2. And I'm going to solve it. So I'm going to take a 3x to that side and plus the 1 to that side. So x is 3 over 2. And then here, this is when the negative branch intersects. So it's minus 5x minus 1 equals 3x plus 2. Expand the bracket. And I'm going to take minus 5x to here to get 8x. Take the 2 over there to get minus 1. So x is minus 1 over 8. I'm just going to check. Right, look, g solve, intersect. Minus 0.125, which is that. And then the other one is 1.5, which is that one. So I know I've got them right. The third one. Oh, sorry, that was the third one. Fourth one. Complete the square form. I haven't asked that for a while, so let's see if you can remember. So I don't want the 3 there, so I'm going to factorize out the 3. Remember, I'm going to ignore the minus 5 for a minute. I'm going to ignore the 3, ignore the minus 5, and complete the square there. To get x plus 2 squared, I have to take away 2 squared, which is 4. Now I'm going to times all of that by 3 and take away 5. I get 3x plus 2 squared, take away 12, take away 5, which gives me 3x plus 2 squared minus 17. So hence write down the value of the minimum value. So the minimum value is minus 17, and that happens when x is minus 2. So no matter what x value I put in there, it's always going to be bigger than or equal to minus 17. That's going to be a important mixture when we look at proof. And the last one, sketching the graph of y equals 3x minus 2 squared, x plus 1 squared. So the roots, well, I've got 2 and 2, minus 1 and minus 1, so bounces and bounces. The y-intercept, I'm going to have 3 times minus 2 squared times 1 squared, which gives me 12. And the shape, I'm going to get 3 times x squared times x squared, so I'm going to get 3x4. It's a positive x4, so an even power. So it starts up here and ends up here. It's going to bounce at minus 1. It's going to go through 12, and it's going to bounce at 2. It's going to look something like that. You can always sketch on your calculator to check.